Hello, statistics students. Welcome to this video on linear regression and modeling linear trends. How much more do people tend to weigh for each additional inch in height? How much value do cars lose each year as they age? Are home run hitters good for their teams? Can we predict how much space a book will take on a bookshelf just by knowing how many pages are in the book? It's not enough to remark a trend exists. To make a prediction based on data, we need to measure the trend and the strength of the trend. To measure the trend, we're going to perform a bit of statistical sleight of hand. Rather than interpret the data themselves, we will substitute a model of the data and interpret the model. The model consists of an equation and a set of conditions that describe when the model will be appropriate. Ideally, this equation is a very concise and accurate description of the data. If so, the model is a good fit. When the model is a good fit to the data, any understanding we gain about the model accurately applies to our understanding of the real world. If the model is a bad fit, however, then our understanding of real situations might seriously be flawed. The regression line. The regression line is a tool for making predictions about future observed values. It also provides us with a useful way of summarizing linear relationship. Recall from chapter 3 that we could summarize a sample distribution with a mean and a standard deviation. The regression line works the same way. It reduces a linear relationship to its bare essentials and enables us to analyze a relationship without being distracted by small details. So this is a review of equations of a line. We'll need this because the regression line is an equation of a line. So the regression line is given by an equation for a straight line. Recall from algebra that equations for straight lines contain a y-intercept and a slope. The m represents the slope and the b represents the y-intercept in that equation for a straight line y equals mx plus b. The letter m is the slope and it tells how steep the line is. The letter b represents the y-intercept, which is the value of y when x equals 0. However, statisticians write the equation of a line slightly differently and put the intercept first. Intercept plus slope times x. They use the letter a for the intercept and b for the slope and write a plus bx. Just remember that the number in front of the x is your slope. The other one's the y-intercept. We often use the names of variables in place of x and y to emphasize that the regression line is a model about two real-world variables. We'll sometimes write the word predicted in front of the y variable to emphasize that the line consists of predictions for the y variable, not actual values. Once we do a few examples, that should make this really clear. And this concludes this video for the regression line modeling linear trends.